In this chapter, you will be learning the following: writing and balancing chemical equations, classifying chemical reactions, reaction stoichiometry, reaction yield, and quantitative chemical analysis. In this video, you are going to learn how to write and balance a chemical reaction. So what is a balanced chemical reaction? A balanced chemical reaction uses symbolism to represent both the identities and the relative quantities of substance undergoing a chemical or physical change. Here is an example. So what you see over here on the left side, you see the substance undergoing the reaction, and they are called reactants. And on the right side, you see substance that are generated by the reactions, and they called products. Over here, you see there is a plus sign over here, and there's a plus sign over here. It separates individual reactant and product formula. The arrow over here separates the reactant and the product. And you can also see here, you see the two coefficients here, you see the two coefficients here. The relative numbers of reactant and product species are represented by these coefficients. Typically, if there's no coefficient in the front, that means it is 1. In this case, CH4, this is methane. So if we don't write anything, we know that this is 1. And for CO2, carbon dioxide, it is 1. These coefficients represent the relative numbers of reactants and products. In this case, the ratio of each ingredient and products, each reactant and products, will be 1 to 2 to 1 to 2. That means for the reaction to happen, we need 1 molecule of CH4, we need 2 molecules of oxygen, and that theoretically can yield 1 molecule of carbon dioxide, CO2, and 2 molecules of water. Or in other words, is also the ratio in moles. That means 1 mole of CH4, methane, will react with 2 moles of oxygen molecule and will give us 1 mole of carbon dioxide and 2 moles of water molecule. The chemical equation described previously is balanced. So how do we know it's balanced? There are equal numbers of atoms of each element are represented on the reactant and product sides. Let's look at the previous example. Over here, let's check, see if it's balanced. How do we check? Let's do the following. Let's check the numbers of atoms of each element on each side if balanced. So what do we have? What element we have here? We have carbon, we have hydrogen, and we also have oxygen. On the left side, I see 1 carbon only. So on the left side, I have 1 carbon. On the right side, I have 1 carbon. Let's look at hydrogen. On the left side, I have hydrogen. How many? I have 4. On the right side, I see hydrogen here. How do I get the number of atoms? There's a coefficient in the front. This coefficient belongs to each element in this molecule. For example, here I have 2H2O In this case, I have 4 hydrogen atoms and I have 2 oxygen atoms. 2 multiplied by 2, that's how I get the 4, and 2 multiplied by 1, that's how I get the oxygen. So in this case, I have 4 hydrogen atoms on the right. What's left? Oxygen. I have 2 times 2, so I have 4 oxygen atoms. On the right side, oxygen appears in 2 different molecules. It's showing here carbon dioxide and showing here as in water. So for oxygen, from carbon dioxide, I have 2 oxygen atoms. And from the water molecule, I have 2 molecules and each one has 1, so I have 2. So that is equal to 4. Let's check again. For carbon, I have 1 on the left side and I have 1 on the right side. So carbon is balanced. For hydrogen, I have 4 on the left side and I have 4 on the right side. So hydrogen is balanced. For oxygen, I have 4 on the left side and I have 4 on the right side. So oxygen is balanced. Each element is balanced. So this equation is balanced. Over here, let's check and see if this chemical reaction, if this equation is balanced. How do we do that? Remember, we are looking for the equal numbers of atoms of each element. See if they are balanced on both sides, if they are equal. For the water molecule here, what are the elements we have? We have hydrogen, we have hydrogen, and we also have oxygen. So we just have to count for how many atoms on each side. For hydrogen, there are 2 on left and 2 on the right. So hydrogen is balanced. That is good. How about oxygen? On the left side, I have 1. On the right side, oops, there are 2. So oxygen is not balanced. So you may say, can I balance it like this? Because oxygen, I have too many on the right. Can I just do it like this? I'm going to do. So how about this? How about H2O with you, H2 plus, because I have too many oxygens, can I do this? Can I just say plus O? See, now I have 2 hydrogen on the left, 2 on the right, 1 on the left, 1 on the right. Can I do it like this? The answer is no, you cannot do it like this. You are not allowed to change this subscript over here, the small 2. You are not allowed to change it. Why? Because oxygen is a diatomic molecule. It always comes with O2. You cannot change the subscript over here. So what can we do? We are only allowed to change the coefficient in order to balance it. Okay? Let me say that again. You are not allowed to change the subscripts. For example, here, water is H2O. You cannot change it to either HO or H2O2. No, you cannot do that. You are only allowed to play with the coefficient. Okay, so let's check now. In order to balance it, okay, so I'm going to give a guess. And by the way, there is no standard way of balancing a chemical reaction. But there is a standard way of checking it, see if it's balanced. All right, so what I'm going to do is, I'm going to put the 2 over here, see if it is balanced now. Okay, if I put the 2 over here, let's check how many hydrogen atoms are on the left. So I have 4. How many are on the right? Oops, I only have 2, so hydrogen is not balanced. How about oxygen? I have 2 on the left side. How do I get the 2? The coefficient 2 over here, multiply this one, so it will be equal to 2. Once again, the coefficient in the front, it belongs to each of the atoms, each of the elements here listed. All right, how about on the right side? What do I have? For oxygen, I have 2. So oxygen is balanced, but hydrogen is not balanced. So what I can do here is, I try to balance it so it can both sides have the same. So what I'm going to do is, I'm going to put the 2 over here. Okay, after I put the 2 over there, let's check everything again. For hydrogen, on the left side, now I have 4. On the right side, I have 2 times 2, I also have 4. For oxygen, on the left side, I have 2. And on the right side, I have 2. All right, so now I have equal numbers of atoms of each element. On the reactant and of the product, they are balanced. They are equal. All right. Okay, so that's what we did. All right, so sometimes you will see additional information in the chemical reactions. For example, if you look at the equation over here, you see the parentheses with the letter S inside. Okay, what does that mean? So in general, when you see the letter G inside the parentheses, that means it's a gas. If you see the L, that means it's a liquid. When you see the S, that means it's solid. When you see AQ, that means it's aqueous. That means it is dissolved in water. And sometimes you will see other informations on the equation. For example, this one, calcium carbonate, will, under some reaction, it will become calcium oxide, solid, and also carbon dioxide gas will be produced. So you can, this triangle over here is pronounced delta. In chemistry, that means it's the heat. Sometimes you can see H, U. That means most likely it means UV, or sometimes it means light as well. H is the Planck constant, and mu over here, it is the frequency. Or sometimes in some textbook you will see HF, where they use F to represent frequency. Okay, let's try an example of balancing an equation. How about let's do the following. I have sodium. Let's say I have sodium Na, and solid. Okay, so let's put S over here. It reacts with chlorine gas. It will be Cl2 gas, and give us sodium chloride, solid, let's say, is NaCl. All right, so let's check and see if this equation is balanced. How do we check? Well, we check the elements, the atoms of elements on each side. All right, so the first thing I'm going to do is I'm going to write down what element I have. So I have sodium, Na. I have chlorine, Cl. On the left side, for sodium, I only have 1 atom. And on the right side, I have 1. So sodium is balanced. What's next? Chlorine. On the left side, I have 2. And on the right side, I only have 1. So chlorine is not balanced. So this equation is not balanced. How can I balance it? I can play with the coefficient. In this case, what I'm going to do is I'm going to put a 2 in front of here, and I'm going to put a 2 here. Let's check now. Now on sodium, on the left side, I have 2, and on the right side, I also have 2. Chlorine, on the left side, I have 2, and on the right side, I have 2. So now this equation is